Hello everyone, welcome to my channel Chemistry by ANR. Today's topic is conformations of alkanes. First we need to know what is conformation. It is the three-dimensional arrangement or the different spatial arrangement of atoms in space. Now when I talk about carbon-carbon bond, this carbon-carbon bond is it can undergo free rotation along the internuclear axis. Why? Due to the symmetrical arrangement of the electrons. So carbon-carbon bond permits free rotation about its C-C single bond. This results into different spatial arrangement of atoms which can change one to the other. That means three-dimensional orientation of the atoms. That is known as conformation, and each orientation is known as conformer or rotamers. Alkanes can have infinite number of conformations because as many times you will rotate around the carbon-carbon single bond, that many positions you will get, that many rotamers, or I can say that many conformers you can get. But keep in mind that it is hindered by a small energy barrier of 1 to 20 kilojoule per mole. Why? Because there exists weak repulsive interaction between the adjacent bonds. But whatever is the repulsive interaction, this repulsive interaction is termed as torsional strain due to the angle strain, the angle that is obtained by the closely spaced hydrogen molecules or the electron cloud. Let us try to understand the conformations of ethane. Ethane is C2H6. So how can we write ethane? We can write carbon-carbon bond is there, and there are three hydrogen like this. There are three hydrogen atoms. This is known as the structure of ethane. This is the structure of ethane. Now carbon-carbon axis means this is the carbon-carbon axis. Around this carbon-carbon axis, you can actually obtain infinite rotamers, infinite number of spatial arrangement of hydrogen atoms that is attached to one carbon with respect to the other. Now they are known as eclipsed, staggered and skew conformation. We will see one by one, we'll understand one by one. There are two representations, one is sawhorse and the other is Newman projection. Now first let me explain to you and then we are going to see the NCERT part. That is, if we talk about carbon number 1 and carbon number 2, for a sawhorse we can say this is the bond, I will say carbon-carbon bond, but it actually doesn't show the carbon-carbon bond length. It's just a representation. So if this is the front carbon having 3 hydrogen and is sp3 hybridized, and so this spatial arrangement around the carbon atom should be tetrahedral. That's why you can see this type of arrangement. Now if the carbon number 2 has hydrogen just behind the hydrogen of carbon number 1, then it looks somewhat like this, and it is as if they are parallel. So this position is known as eclipsed position, where you can actually see one hydrogen is just behind the other. One hydrogen is just behind the other. This is carbon number 2, this is carbon number 1. We need not write the C atoms. We just need to draw the bond and we just need to locate the hydrogen atoms. Now, if I keep this C1 as fixed, so I don't change the C1, I keep it fixed like this, only tetrahedral, and I change by the hydrogen, the carbon hydrogen bonds of C2 by small angles, little angles, by rotating it by small angles, and we ultimately come to a point where the hydrogen will be just anti to the reference hydrogen like this. So it is as if anti to it. So this type of arrangement is actually known as staggered arrangement, where the angular repulsion is considered to be minimum. So we will say minimum repulsion. And so this staggered conformation is considered to be the most stable conformation having minimum energy, because stability is more, so energy is less. And in eclipsed we can say maximum repulsion because of the closer dihedral angle, torsional angle. What is that? We will see later on. Maximum repulsion, for that reason we can say it is having least stability, and since it is having least stability, it has maximum energy. Now there are infinite possibilities of the spatial arrangement between one eclipsed and the other staggered, and all these possibilities are termed as skew conformers. They are the intermediate conformers, the infinite number of conformers that are possible between an eclipsed and the staggered. So now Sawhorse projection, just the way I told you, this is your C1, this is C2, and I hope you can understand why this is eclipsed and why this is staggered. This is your C1, this is your C2. Seeing this as Newman projection, keep in mind, we just don't show the carbon-carbon bond. Like if I say Newman of eclipsed, what will happen? Newman of eclipsed means, suppose I say this is the front carbon, here it is located. This is the front carbon and it is having 3 hydrogen like this. This is 1, this is 2, this is the other, and the 4th bond with the other carbon is just behind this pair and it's not being seen. Now the behind carbon, the C2, is again having 3 hydrogen. If it is in eclipse position, then it will actually be one behind the other. And if I need to show by minimum angle, I need to show in this manner. And I will assume that this angle is almost equal to 0 degree. And this angle is known as dihedral angle or torsional angle. It is also known as torsional angle. So this is 0 degrees, so the repulsion is maximum. So this is your eclipsed form in Newman representation. If I try to show you the staggered form in Newman representation, we can see over here this dihedral angle, each is 60 degree, each is 60 degree. And then it forms how many 60? 1, 2, 3, 4, 5 and 6. So this is, each dihedral angle is 60 degree, which is of course experiencing lesser repulsion where the dihedral angle was considered to be 0 degree. So staggered is the most stable form. That is a relative stability on account of the torsional angle or torsional strain. Now, if anyhow, I want to show you energetically, this is the energy profile and these are the conformations, and I say, chalo, these are the energy of one of the conformer, this is another, and this is another. Say this is A, B, C, D and E. Then which is what conformer? From this diagram we can say A and E is having minimum energy and so they are what? Yes, the staggered conformer. They are the staggered conformer. C is having maximum energy and so this is the eclipsed form. And B and D, they are in between staggered and eclipse, and so it is Q form. So I hope the conformers are clear, the concept is clear. So bye all of you, see you with the next module, that is alkenes.